Okay, welcome to the lunch time video, my favorite video. So it's going to be a new topic today, and it should be a pretty easy one. Let's pull it up and see what the topic is. Okay, so the topic is going to be route targets. I feel like I've kind of gone over that enough in the past. In the 961 version, I went really into depth on route targets, so I don't think this will require more than one video to get through. So what we're going to do is go into the lab and use my existing topology and play around with that. Maybe try a different kind of route target. Right now we've got one that's a community string. So we'll play around with the different ways to configure a route target, and then regardless of what happens, move on to the next topic in the after work video. There's going to be an after work video today, well, every day, because I'm scheduled on the 18th, so I've got less than 30 days, and probably even less than 25 days at this point before I actually take the exam. I've got my official exam instructions, so I'm going to need to go through all that sort of thing, get myself set up. Yeah. And then there's, of course, a bit of a problem where, because you need an account that's tied to an employer, I clearly have my employment PC that is property of my employer that I'm using, and then I have my own PC that is my own personal property, and it's a little bit confusing to me where I would take the test. Would I take it on my employer PC because I have to use an account tied to my employer, or would I take it on my personal PC because it's, I'm the one personally registering for the exam. I'm not doing it on the behalf of an employer, so I don't understand the details of the registration, administration, bureaucracy side, but that's probably my greatest weakness, is understanding that sort of stuff. So I'm just gonna try to not have it throw me too much, and I think I'm biased to want to do it on my personal PC just because it feels like more of a personal activity. So I'll just see if there's a way to make that happen, and if it's impossible to do it that way, I'm sure there won't be any issues using my work PC for that. And I have all my tools. I have better tools on my work PC anyway. Better terminal and stuff. Okay, so let's so let's start out the video the same way I start every way. We're gonna do we're gonna do help apropos. So now we've got a topology set up, perfect, everything's good to go. Now I did have a question in the last video, and the question was, now that I have enabled IPv6 tunneling, do I need to include INET 6 on there? So the answer to that is yes, I will need to include that there if these routes here disappear from the table. If they don't disappear, then I won't need to include that. So let's go to BGP. Okay, and then let's remove that statement. And then let's see if those routes disappear and I'm no longer able to ping them. So before I commit that, we're going to do a run ping 172::1. Oops, and it looks like there's something. Oh, right. Okay, so it would be from the Cisco where I would test that. So yeah, let's do that, and we'll have a ping going. So ping 172::1, source 172::3. Okay, so yeah, everything looks good there. So let's try erasing that configuration line. Okay, and then once that's erased, we'll try pinging it again. So yep, very clear answer. Couldn't get any clearer than that. That is a required configuration. Oh, yeah, success rate is 0%. Okay, so let's add that back in there because we're going to need that to work while we're playing around with route targets. Okay, and then let's do a help apropos for route targets. Targets. So here we go. Couldn't get any better than that. Yeah, I mean, looks like there's a number of hits. Now remember, this is layer 3 VPNs. So for MVPN, I think that's going to be a layer 2 VPN. I think. I'm going to double check that. I guess. Oh no, it's going to be a multicast. Yeah, so it's right here, NGM VPN. So it's a multicast. Okay, so Okay, so I think those three are going to be okay. Yeah, I think those three are going to be fine. We've got, I might as well include the MVPN on there just as like a foreshadowing for because I'm going to need to copy this to get to this eventually, so I might as well prime my brain to latch onto it quicker when it comes down the pipe. Okay, so yeah, let's start. Let's start with this one. Configuring BGP route target filtering for VPNs. BGP route target filtering is enabled through the exchange of the route target address family stored in the bgp-rtf.0 routing table. Based on the route target address family, the route target NLRI address family indicator AFI equals 1, subsequent address family indicator SAFI equals 132 is negotiated with its peers. On a system that has locally configured VRF instances, BGP automatically generates local routes corresponding to targets referenced in the VRF import policies. To configure BGP route target filtering, include the family route target statement. Okay, so let's see what statement I have enabled. We'll check PE router E. Okay, before moving on, I'll just make sure that everything is back. It is. So let's see what kind of configuration I've got for my route targets. Okay, so I've got, let's see here. What have I got? I don't even know. Oh, okay. Yeah, so here's my target here. It's a community string. So I don't even necessarily have a route target. I've just got a community string that's the same syntax as a route target. So it serves the same purpose. But I definitely don't have it under family route target. So let's go in and explore how that would look. So yeah, so what I could do is instead of yeah, so I'm a little bit confused here because I'm not sure where this is meant to be configured. Is it meant to be configured yeah, I'm not sure if it's meant to be configured in the BGP configuration that belongs to the custom routing instance or the iBGP configuration that's used to exchange iNet VPN NLRI, because this is not meant to exchange VPN NLRI. This is used for after it's exited the VPN, and then once it's inside the VPN, this is what it uses, and that's why you need the -VPN family. So I would think it would be added to here. Let's start there. Okay, and then we're going to do set family route target unicast. Let's go into edit family. Oh, it looks like I went to traffic engineering instead by accident. Let's go to edit family route targets. There we go. Now I no longer have the option for unicast because it's route target instead of traffic engineering. So okay, so now you can do advertise default, external paths, and prefix limit. For a list of hierarchies at which you can configure the family route target statement, see the statement summary section for the statement. The advertise default, external paths, and prefix limit statements affect the BGP route target filtering configuration as follows. The advertise default statement causes the router to advertise the default route target route 0:0:/0. So this is the default route target route. So you can see it's in a much different format than an IPv6 or an IPv4 address. That's because it's in the route target format. And suppress all routes that are more specific. This can be used by a route reflector on BGP groups consisting of neighbors that act as PE routers only. PE routers often need to advertise all routes to the route reflector. Suppressing all route target advertisements other than the default route reduces the number of information exchanged between the route reflector and the PE routers. The Juno software further helps to reduce route target advertisement overhead by not maintaining dependency information unless a default route is received. The external paths statement, which has a default value of 1, causes the router to advertise the VPN routes that reference a given route target. The number you specify determines the number of external peer routers currently advertising that route target that receive the VPN routes. The prefix limit statement limits the number of prefixes that can be received from a peer router. The route target, advertise default, and external path statements affect the RIB out state and must be consistent between peer routers that share the same BGP group. The prefix limit statement affects the receive side only and can have different settings between different peer routers in a BGP group. For examples illustrating how to configure BGP route target filtering for VPNs, see VPN examples. So I kind of want to see that. Let's match VPN, match example. So yeah, we got lots of VPN examples. Let's try target or filter. Match filt. Match targ. Okay, so I don't see anything easy for that. Okay, so yeah, I'm not sure what's going on there. Yeah, let's just move on to the next one that I had saved. But these are looks like this is pretty valuable here. Unfortunately, it's just a lot of information, so it's hard to go through and see. Pipe match. Yeah, this is something I might be able to do, is just add pipe match route target, so I can like just grab all of the examples here. And I'm probably going to need to do something like this during the test too, because I'm just worried about sitting down, and this has happened to me in the JNCIE-SP. You know, I'm sure this everyone can relate to this. Sitting down at the computer, opening up the test, reading the question, and having just not the first clue as to what the answer could possibly be. I'm sure that's relatable to just about anyone for just about any test. So the idea is to have that happen as few times as possible, but for a test like this, where it's hands-on, it's not multiple choice, you really got to come up with a strategy for multiple tests. There's strategy for multiple tests as well. In case anyone hasn't heard, this will be pretty useful. So if you sit down to a multiple choice question, and you say, I have no idea what the answer could possibly be, not even the first clue, what you can do is you can reframe the question. You can say, instead of trying to figure out what the answer is it possible that I would know for sure what the answer isn't? Can I look at these choices here? We've got 4 choices, and can I find one of these choices that I know for sure isn't going to be the right answer? And if you can do that, then instead of guessing on 4 questions, you're only guessing on 3 questions, and you have a much higher probability of just randomly guessing the right answer. So there's a lot of strategies like that for multiple choice. So for hands-on like this, there's also going to be strategies, but unfortunately, I'm going to need to make up my own. And this sort of thing, I think, is more than fair game. Just filtering through all the help and using the help menu the best I possibly can use it. You know, it's just about CLI, command line competency, really. When it comes down to it, you should be able to use the help. Python as well, if you're learning the code, there's built-in help. So using help, I think, is a skill. Being able to get the answers you need. So I wish there was an easier way to do this. I think there is, actually. So let me do, well, you know what? I think I'm good for now. See, this is time consuming. I made a Cisco help helper that would make this faster, but oops. Okay, I'm almost done with it though. I do need to be careful because I can get into a kind of a trance where it's like I'm doing something like this and then I don't realize that it's no longer necessary, and I do it for a half an hour, even 15 minutes can make a huge difference. And before I know it, I'm out of time on the test because I wasted my time trying to dig through the help documentation when I did not need to do that. That could be a huge problem. But I think this strategy is definitely a sound strategy. We're just gonna go through and we're going to, oh, it looks like I grabbed too many. There we go. Yep, I grabbed too many, so let's grab like 4 at a time, and then go through and see if we've got that. And I'll make sure to do yeah. Yeah, so if I'm absolutely, completely beyond, you know, beyond imagination, stumped, I can, of course, I can do this. I can, the other thing I can do is do trace options. I'll probably do trace options first because I can use the things I saw in trace options to kind of determine what kinds of search terms will be more useful. Yeah, I do have that helper script, which would be good in this case, but unfortunately it does take it a long time to run, and then memorizing a script is probably a bit too much to ask, especially if I won't get much value from it, or can use a different method such as this. Yeah, so now this is going to work here because we saw in the help menu here, yep, route target. So this BGP route target filtering is something that we can see is really uncommon. It's really going to only be showing up in specific situations. So I'd be actually pretty surprised if it didn't show up in any of this documentation. But yeah, I would be pretty surprised if it didn't show up in any of this documentation. Nothing yet. Huh. Oops. Aha, so it looks like, did I get one? No, I didn't get one. Okay. Yeah, because I'll see an extra line pop up, so it just kind of confused me. Okay, so I think we got one now. No, it just, sometimes it doesn't word wrap. Okay, so this is actually kind of fascinating. It almost looks like this method of route target filtering in BGP is not showing up anywhere in the examples. Yeah, I'm really surprised to see that. I am kind of curious to see if my OP helper script will help here. Okay, we got it. So here we go. We got it. We've got hits now. So it's going to be, yeah, this bgp-rtf section. Okay, so let's see if it shows up in this as well. Okay, nothing there. And let's check these. Nothing there. So you can see the power of this route target filtering. We've got a whole example here with 3 PEs and a route reflector. So I can get rid of this, and I'll be able to use Notepad++ on the exam, from what I understand. And yeah, so let's take a look. Okay, so this is bgp-rtf, BGP route target filtering. So there we go. RTF stands for route target filtering. For VPNs overview. BGP route target filtering is enabled by configuring the family route target statement at the appropriate BGP hierarchy level. This statement enables the exchange of a new route target address family, which is stored in the bgp.rtarget.0 routing table. The following configuration illustrates how you could configure BGP route target filtering for a BGP group titled to titled TO_VPN04. Okay, so yep, you would put it in your internal BGP groups, and then you would just add family route target there. The following configuration illustrates how you could configure a couple of local VPN routing and forwarding VRF routing instances to take advantage of the functionality provided by BGP route target filtering. Based on this configuration, BGP would automatically generate local routes corresponding to the route targets referenced in the VRF import policies. Note the targets defined by the route target statements. Okay, so this is going to be a bit of a difference here, because in our VPN-A custom instance, we don't have a route target specifically defined. We have a import statement and an export statement that tie into a community string that is this same syntax. So I'm not sure if this VRF target command is necessary, or if you can satisfy the criteria of that command using those import and export statements instead. Issue the show route table bgp.rtarget.0 show command to verify the BGP route target filtering configuration. The show command display format for the route target prefix is AS number, route target extended community / length. The first number represents the autonomous system AS of the router that sent this advertisement. The remainder of the display follows the Juno show command convention for extended communities. The output from the show route table bgp-rtarget.0 command displays the locally generated and remotely generated routes. The first two entries correspond to the route targets configured for the two local VRF routing instances, VPN1 and VPN2. The last two entries are prefixes received from a BGP router. So 200:200:103, we can notice this is a pretty strange syntax here. It's the route target syntax. /96 tells the local router that routes tagged with this community 200:103 should be advertised to peer 10.255.14.174 through TE000.0. 200:200:104/96 tells the local router that routes tagged with this community 200:104 should be advertised to peer 10.255.14.174 through TE3.000.0. So the same peer and the same router, the same interface. Okay, so this was I think pretty good documentation, especially by the standards of this documentation. So what I'm going to do is in this first video here, go ahead and work towards having a topology like this. So it's going to be at least 4 routers, 3 PEs, and a route reflector, and then CE routers as well. So let's see here. So 3 PEs and a route reflector. Let's see what we've got so far. So we've got 3 PEs, and we don't have a route reflector, but we have a PE. So yeah, it looks like, you know, what I can do is just keep this same topology, but change it so that it's pointing to a route reflector, and then set up BGP route target filtering on this. And that's what I wanted to do anyway. I wanted to eventually reconfigure it to use a route reflector anyway. So 2 birds with 1 stone. Let's so let's see what the configuration for PE1 looks like, which is going to be router B in my topology. Okay, so here's the configuration for PE1. So we should have, okay, yeah, so we're going to have a new neighbor statement as well. It's going to be pointing to the route reflector. And then we should see in the route reflector configuration what that looks like. But the PE configuration, just because we were using a route reflector, it's not going to be any different. It's just going to be pointing to the route reflector instead of the full mesh of PEs. I am a little bit confused about what is required for the MPLS LSPs. Do they still need to be in a full mesh with each other, or do they all point to the route reflector? I would think that they all need to be in a full mesh with each other, because there's a difference between the LSPs and the IBGP configurations. The IBGP configurations are meant for exchanging the routes, and so that every router knows how to send traffic, but the MPLS are meant so that the MPLS LSPs are so that each PE knows where to send the traffic, I believe. So you would treat the MPLS LSPs as if they were actual physical wires, and you would plug them into the other side. The BGP-IBGP neighbor statements, those aren't virtual wires. They're just saying, where do I get my information about what my routing table needs to be filled in with. So if you don't have a route reflector, you've got to get that information from the other routers in topology. If you do have a route reflector, that information is all aggregated into the route reflector, so you just get it from the route reflector. Okay, now I've got to take a quick break. I'll be right back though. All right, I'm back, so let's get started on reconfiguring this topology to do route target filtering and to use a route reflector. So I think one of the things I'm going to do is just grab all of the configurations and lay them out in Notepad++. So the pacing I can do, if I do one topic a day, I'll be fine. I can kind of mess up and do a topic over multiple days, but if I get in the habit of doing that, I will run out of time. So I don't know if it's better to go into depth on one particular topic and then gloss over other ones, or to give equal time to every topic. I'm probably going to try to err on the side of giving time to every topic, especially since I can use the help, and it'll be easier, I think, to refresh my memory than to learn something new. Because like even with this, like now that I know that it's -RTF, route target filtering, like it'll be easier for me to look up the stuff on exam day. Okay, so I'm gonna clean up my notes here. Instead of all this, these are just going to be the extent of my notes, because this is going to be the extent of this video, is getting through and configuring all these. So yeah, let's start with router 1. We're going to have a few changes here. First of all, we're going to be pointing to the route reflector. We're also going to be using a family route target for the IBGP. So let's start with that. Let's start configuring family route target on all of the PEs and see if we get any error messages, anything like that. Okay, so let's do a commit check on that. And I could have just done a regular commit. I guess I'm not sure if I wanted to go live or not, so that's why they did the commit check instead of the regular commit. So the commit check succeeded. So yep, I can have that go live now if I choose to. Let's just read the rest of this before I have that go live. And here we can see the export statement to the CE that I was missing in the last video. Okay, so we should get a special bgp.rtarget.0 table showing up after I have committed that. So let's verify that that table is not here currently. Okay, so here's all of the tables we've got right now. I don't see a bgp.rtarget.0 table, so let's try committing that config and see if we get a new table. Yep, so now we've got a brand new table, bgp.rtarget.0, and that's because if I do a rollback 1, show pipe compare, that's because we added this family route target statement to protocols group to the IBGP. So to roll that back would be to remove it, but I don't think I'm going to do that, so I'll roll back 0, leave that on there. So now the thing is, they're going to have it populate with information, but I don't think currently it is filled up with anything. So we do have some information in here. We have 2:100:1001, and then we have the default. So let's take a look at display set pipe match target. Let's take a look at the community string that we created that uses that same syntax as a route target. Okay, so it looks like we've got something similar to that showing up here. I'm not sure where this number 2 came from. Maybe that's the show routing options. Yeah, maybe that's the autonomous system. So it probably does autonomous system and then the numbers in the route target instead of the TARGET characters. It swaps out this part for the autonomous system, it looks like. Okay, so yeah, okay, so let's go and add that to the other routers. We'll just start with that, and then in the next video, because I'm going to run out of time pretty quick, we'll be setting up the route reflector. Okay, so that's it. I've even got it memorized right now. It took me a little bit to recall it, but it is should take me a lot faster on router D. Perfect. So yep, nice and speedy on router D. got that committed to memory. I know what it does. It creates a new routing table where it exchange actual route targets. So let's take a look at that. Yep, and then that can be used for filtering. So yeah, now I don't see, I'm kind of surprised that we don't have extra stuff showing up in this table. Oh, it looks like as I was printing this out, we are getting things populating into this, so maybe it's just not completely populated yet. Okay, so it looks like we've only got the one route target, which makes sense. Yep, and then we're learning it from two different routers. Perfect. So this is actually what I would expect to see. Let's see if it looks that way on all of the routers. Oh, I gotta say table. Yep, so this is exactly what I would expect to see. Yep, through a label switch route. And I think even after I change it to the route reflector, we're gonna see the exact same thing. Because it'll travel through the label switch route, we'll see. But yeah, everything looks good here. Just simply enabling that route table allowed it to automatically fill in the route target and specify where it had learned from, and we can see it's learning it from both sides. So yeah, no problems there. Yeah, so I think I'm gonna end the video, and then in the next video, at the after work video, I will be adding this configuration here to router C, which will serve as the route target, or sorry, the route reflector. And then we'll try actually filtering something using route target filtering. Okay, but I'm going to end this one, I think, a little bit early. Yep, I'm going to end it a little bit early to give myself time to get to my 1 o'clock meeting and to upload it. So thanks for watching, and I'll see you in the next one.